G'day Year 11 and 12. We are now going to do the last lesson in working with time, and this is a lesson that I didn't have to run last year because they took this horrible part of general mathematics out, and we didn't have to do it anymore. And this is the first of those changes that came through in November that I mentioned that's been brought back in. What I find horrible about this is it's kind of something that doesn't actually get used in practice. It doesn't really exist in that it doesn't really get used. So this is talking about what's called local or true time, or probably better described as sun time. So obviously the world's time zones are split up according to the way countries want them split up. And as we mentioned in a previous lesson, if you're going by the sun, the Northern Territory should be an hour behind New South Wales, Queensland and Victoria. But in reality, it's only a half an hour behind. And daylight savings, of course, is another way in which we alter what sort of the sun naturally does. So, of course, if I was wanting to measure, I guess, the sun time, I suppose if I was more concerned with, the time of the day that UV is going to be the highest or those sorts of things, then it doesn't really matter what time of the day I call it. It matters what the position of the sun is. And so we have this thing called sun time, which, as I said at the top here, I've never seen this used ever. But it is something that it's a mathematical process. But I'm of the opinion that if we're doing a course that's using applied maths, we should use maths that's actually applied. I don't think I've ever seen this really applied in real life. There might be somebody out there that can prove me wrong. So nonetheless, we just have to break down and remember these basic bits here. I find that one there is the most easiest to remember, that 1 degree of longitude equals 4 minutes. And the reason why I think that one's the best one to remember is if you use your calculator, you can work your way around everything else. So I don't need to remember that 15 degrees is an hour and that 360 degrees is a whole day or 1440 minutes. I think it's just easier if I remember 1 degree is 4 minutes. It's one thing to remember, and then I can use my calculator to fix everything else up. So obviously here we've got, remembering of course with just like time zones, we've sort of got a 0 in the middle, and we can either go east or west, obviously. So think of your east as your positive numbers, think of your west as your negative numbers. And once again, I would advocate using a timeline. So the example given here is Sydney and Alice Springs. So let's do that as I'll get a better pen for that. And so if we think of a little timeline here, number line, we've got Sydney here at 151, and we've got Alice Springs here at 134, and way down here is 0. So we're looking at the distance between those two. So obviously take the most easterly away from the most westerly. So we've got I'll call it the longitude distance, is just going to be 151 minus 134, which is 17 degrees. Now, at this point, I think the easiest thing to do is use your calculator. Once you know what the difference in longitude is, plug that into your calculator, 17 times by, and then just press 0 hours 4 minutes. And so that'll multiply 17 by 4 minutes, but as well as doing that, it'll give you an answer in hours and minutes. So it's 1 hour and 8 minutes. And I'll show you that process again now with this second one. So we're going from Paris to New York. Now this time we've got a line that starts at, if we imagine this here is 0, that's London. 2 degrees east is here, and that's Paris. And then we've got 74 degrees west, and that's going to be New York. So obviously the distance we've got that we're interested in is the one from New York all the way to Paris. So once again, as I did last time, get the most easterly, take away the most westerly. So longitudinal distance is going to be 2 minus, and we consider west as a negative number, so minus 74. So 2 minus 74, which is 2 plus 74, so that's 76 degrees. And then what we do is we use our calculator and we plug that in, and what I might do is I might save that screen. So 76 times by 0 degrees 4 minutes, and we hit equals, and that's going to give us 5 hours and 4 minutes. as our answer. I'll just take a quick snapshot of that. And we'll pop that there. And I'll just drop him across here so you can sort of see how that's done. So okay, so that's that basic system there. We can then use the same process to answer questions like the one here. If it's 7 p.m. in Beijing, what time is it in all those cities? And I think the best way to start is probably just to put all of them on a number line. So they're all east, so the most westerly of those is going to be 73 degrees, and that's Mumbai. And then we've got 121 degrees, which is Beijing, our reference city. And then Tokyo is 140. And Sydney is 151. Okay, so if we consider our time differences for A, B, and C, so our longitudinal difference between Tokyo and Beijing is 19 degrees, 140 minus 121. For Mumbai, we'll do the other way. We'll go 121 degrees is the most easterly, so 121 take away 73. I might even use the calculator for that one. So 121 take away 73. And that gets us 48 degrees. And then finally, Sydney is 151. Beijing's 121, so the difference there is going to be 30 degrees. We're obviously multiplying all of those by 4 minutes. So as we plug that all through the calculator, we'll just go 19 times by 0 hours, 4 minutes. So that gets us 1 hour and 16 minutes. And we can use that replay function on the calculator and go back up there and just change the number we're multiplying by for these ones. So 48 for the second, so that's going to be 3 hours 12 minutes. And for Sydney, we'll go back up and change that 48 to a 30. And there we go, that's 2 hours. Now, that's not the end of this question. We've got to actually find what the time is in those places. So anything further to the east is going to be later in the day. Anything further to the west is going to be earlier in the day. So if we're starting at 7 p.m. in Beijing, Tokyo is further east of Beijing, so it'll be earlier there. So it'll be an hour and 16 minutes earlier. So therefore, it's going to be 8:16 p.m. And for the second one, which is Mumbai, this is further west of Beijing, so it's going to be 3 hours and 12 minutes behind. So it's 3 hours and 12 minutes before 7 p.m. So probably the easiest way to do that is to put 7 p.m. is 1900 hours, so 19 hours, no minutes, take away 3 hours, 12 minutes. And that's going to give us 1548, which is 3:48 p.m. And finally, Sydney is 2 hours in front, so it's just going to be 9 p.m. for Sydney. I'm just going to take a quick pause there. Okay, so just to catch up, I've gone ahead and done a couple of things just so I don't run out of time on this video. I want you to skip this particular question here. I actually think it's probably needs to be reworded, and I'm just going to take that one out of there. It's too easy to confuse with the questions we were doing previously. So we're going to go to example 4. So Osaka is at 135 degrees east, Denver is 105 degrees west, and we want to show there's a 16-hour time difference. So what I've done is I've drawn up a bit of a number line there. There's Osaka at 135 east, Denver at 105 west. So the longitudinal distance difference is going to be 135, take away negative 105, so it basically becomes an adding. And once again, we use that same basic idea. We can pull up one of the previous ones that our calculator we used, but we just multiply however many degrees it is by 4 minutes. And we end up with 16 hours, so you can see there, that's clearly showing that they're 16 hours apart. So just moving on from there, John lives in Denver and wants to ring his friend in Osaka. In Denver, it's 9 p.m. Monday. What day and time is it in Osaka then? So if it's 16 hours later in the day in Osaka, because Osaka's further east, when it's 9 p.m. In Denver, that time has already happened 16 hours ago in Osaka. So we need to add 16 hours on. Now, obviously, it's going to take 3 hours just to get from to midnight as we add the time on. So my children are arguing at the moment, so I'm sorry if you can hear that in the background. So there's 3 hours to midnight, and then there's a further 13 hours past midnight. So therefore, it's 1300 hours on Tuesday, which of course we can write as 1 p.m. Tuesday. Now the next one, you could do a bit of jumping around a bit, but I think it's probably good to have a bit of a think about this one. So John's friend in Osaka sends him a text message which happened to take 14 hours to reach him. And it was sent at 10 a.m. Thursday at Osaka time. And what was the time of day in Denver when John received the text? So the first thing we got to think about is what we've got here is we're now in Osaka. So it's actually going to be 16 hours earlier in Denver. So if it's 16 hours earlier in Denver, but it takes 14 hours to reach him, then essentially what's going to happen is it's going to arrive 2 hours before the same time in Osaka. Now you can do the additions and subtractions, but it's a little bit more difficult. But if you just think about that concept of 16 hours after 10 a.m. Thursday Osaka time, it's going to be 10 a.m. Thursday Denver time. And this is taking 14 hours to reach Denver. So essentially 2 hours before 10 a.m. Thursday Osaka time is when this is going to arrive. So sort of the 14 hours just seeing how I'd write this down. I'll make that look a little bit neater. 14 hours to arrive, but 16 hours earlier. So therefore, 2 hours before initial time in, where were we, Osaka. So we're going to go with therefore 8 a.m. Thursday. Okay, now really important with these particular questions, it's written down here, old text exercises. Please make a note of that. Don't go and do 10D in the current textbook. You'll be doing something on data or something. It's not the right thing to be doing. So if you have the booklet, it's the next few pages in the booklet is exercise 10D. I think there's 3 pages. Alternatively, if you're looking on OneNote, go to text and there is exercise 10D there and just do the selected questions from there. Do get your head around this. If they put it back into the HSC, then chances are they're likely to ask a question about it. Yeah, it's probably something that one of those things that we'll put under the heading of you learn so you can do your HSC, and then you'll forget you ever learnt it unless you get into some strange meteorology department where you need it. So have a crack at those. We'll have a Zoom session coming up. If you have any questions about it, please ask me then. Cheers.